Human geography brings a unique perspective to the study of human activities, past, present, and future. The geographical perspective adds something. It focuses attention on where activities take place. And in so doing, we see both how geographic context influences what happens and how people make the places where they live, work, and play. Places that are unique. From an Iron Age village in Europe, to a ball court in an ancient Maya city-state, to a paddy in China, to a casino in Las Vegas, to Silicon Valley in Northern California, to a playground in Middle America, to an ethnic neighborhood in New York City, to a fishing village in Greece, to a dairy farm in Ohio. Human geography also focuses on the distribution of places and human traits across the globe and their connection to one another. I am Alec Murphy, and in the series Human Geography, Making Sense of Planet Earth, I will show you how some of the most significant places and patterns that define our planet came into being, and how they shape what happens, whether it be in the realm of economics, culture, trade, religion, migration, scientific invention, ideas, agriculture, or human development. As the human population has grown to over 7 billion people, nothing has had to change more than the geography of agriculture. Change to sustain this incredible, ever-growing population. The cultivation of plants and animals. This primary relationship between people and the land is the topic of this 5th program, Agriculture and Rural Land Use.
There is nothing more that humans have done to change the landscape of the planet than to cultivate the land. Incredibly, over 40% of the Earth's land is now given over to agriculture. And that figure is rising. Let's look at how geography, place, and agriculture fit together like hand in glove. There is the wheat-growing region of North America's Central Plains, the olive groves of Greece's Mediterranean climate, dairy farms near urban centers, the irrigated vegetables of California's Central Valley, the rainforest gardens of the Yucatan Peninsula, the cattle ranches of northern New Mexico, citrus groves of central Florida, sheep ranches of northwest England, and sunflower fields in Argentina. Sunflower fields that are there partially because of soil and climate conditions, but also because of the diffusion of a plant from the northern hemisphere. And just as importantly, because of the global market that has created a demand for sunflower seeds and oils.
So, different crops, such as sunflowers, wheat, corn, and the like, show up in different places across the globe. Understanding how this distribution came to be is a major geographical question. It begins with understanding the origin and the spread of agriculture, the origin and spread of the cultivation of plants and the domestication of animals. A process that started when humans deliberately tended plants for the production of food. Before that, we were hunter-gatherers.
For many modern urban dwellers, it's hard to imagine small family groups. Groups or clans living directly off the land. Hunting or fishing, gathering fruits, nuts, and roots, as this Amazon rainforest family is still doing today. Yet that's how people lived for most of human history. Where they lived was greatly influenced by physical geography. People were tied to water corridors, forest openings, and coastal shorelines, as was the case with the Indian tribes of the Pacific Northwest. Today, less than 300,000 people actually live solely by hunting and gathering, without some connection with agriculture. Agriculture that began a number of times in a number of different places from what geographers called hearts.
When you think about how people switch from being hunter-gatherers to concentrating in cities or in agricultural civilizations and settling down, there's really two camps. One is the idea that people settle along fresh water sources like the Nile or the Tigris and the Euphrates. And that concept really says that agriculture begins with some level of irrigation and with people needing a fresh water source. The other theory comes from Carl Sauer, which is the idea that people settled first in places with volcanic soils and mountainous kinds of highlands environments like you get in central Mexico and in the Andes. And the idea there is that you have lots of diversity of plant life in a short distance, because with elevation change you get different climates, and so people could experiment with lots of different plant life in those places, in those highlands kind of climates. I think it really has to do with agriculture.
It is well known that there are basically two ways to cultivate plants. One is by gathering and planting seeds, and the other is by taking cuttings from existing plant stems or roots. Vegetative planting, which occurs when you take a slice of potato and stick it in the ground, appears to have originated in three primary areas. Starting in Southeast Asia with plants such as yams, bananas, and palms. Vegetative planting spread in all directions, eventually ending up in Africa and the Pacific Islands. Secondary hearts of vegetative planting may have originated in the Mediterranean and spread north into Europe. And in the Americas, crops such as the potato and sweet potato were staples of another region of vegetative agriculture in the northern Andes of South America. The cultivation of these plants spread east and north. Indeed, eventually they made it to Europe, particularly Ireland.
Seed crops, such as this wheat behind me, had their own places of origin. Cultivating plants that produce edible seeds prompted our ancestors to develop new technologies and agricultural practices. It led them not only to harvest seeds, but also to store them for eating later. It required preparing the soil and understanding the seasonal cycles of a particular climate. And, as we shall see, it began the process that today we call genetic engineering, choosing the seeds from the most robust plants for next year's planting. Let's look at the primary places of origin for seed agriculture.
In the Old World, there are three hearts of seed agriculture: present-day Ethiopia, Western India, and northern China. In the New World, there is again a hearth in the Andes and one in present-day southern Mexico.
So agriculture has developed independently across the globe. Each location, soil and climate, resulted in a unique assemblage of cultivated plants and domesticated animals, along with unique agricultural practices. But there are also certain common characteristics among all early agricultural systems. Characteristics that lead geographers to regard them all as part of the first agricultural revolution. All agriculture arose after the last ice age. Tools for agriculture became just as, if not more, important than weapons. Nomadic lifestyles were replaced by sedentary lifestyles. The search for better hunting grounds was replaced by the search for more fertile land. And of course, some wild animals and plants became domesticated. The first agricultural revolution not only resulted in the domestication of plants and animals, it also domesticated us.
The first agricultural revolution, what an exciting time that was. That was in the Neolithic. And, there's the notion that the development of agriculture increased the carrying capacity of the Earth's surface 6 times. Because the argument runs that a hunting and gathering population in a really good environment can hold about 1 person per square mile. The basic farming system can support 6 people per square mile. So bang, all of a sudden the ability of the human population to extract energy from the environment, and that's what we do, how we live. We extract energy from the environment. Our capacity to extract energy from the environment increased dramatically, and it has been increasing ever since.
So if you think of hunters and gatherers, everybody has there's an equal power distribution because everybody is sort of out fending for themselves. When you bring agriculture in, and specifically agriculture in the form of grain, what grain does is it reflects a condensation of power. You can kind of condense it because grain can be stored. Grain can be stored, and so the minute you can store that food energy, and you have somebody who has the ability to store it, you have suddenly uneven distribution of power. Because if I can store the grain, and if I can, for example, influence how much grain you can grow by controlling the water you have for your fields or whatever, the power becomes more centralized. It's not as evenly distributed. And because you can store that energy in the form of grain, I can pay you in grain. I can trade the grain. I can sell the grain, which you can't really do in a hunter-gatherer society quite as easily. So I think with agriculture, it's kind of an interesting step toward an uneven power. And when you start thinking about the minute you have a little bit of uneven power in the form of a little surplus food and a little control over that food, that gives one party some influence to develop other things like weaponry or science or other kinds of cultural advances. When you have a little bit of an edge over somebody else, you could take over a little bit more territory and you could tell them a little bit more how you want things to go. So I think the initiation of agriculture had a lot to do with pulling a little bit of power towards some people and away from a more even-based society.
At any modern supermarket, one will find a plethora of fruits and vegetables. In the early 1950s, cultural geographer Carl Sauer identified 11 regions from which most of these fruits and vegetables originated. Here is a sample of what came from where. Lower Southeast Asia mainland and Malaysia, coconuts and cloves. The Upper Southeast Asia mainland, many citrus fruits and teas. North Central China, soybeans and apricots. Eastern India and Western Burma, eggplants and mangoes. Southwest Asia, apples and cherries. Mediterranean Basin, lettuces and sugar beets. Ethiopian and Eastern African highlands, peas and coffee. Western Sudan hilllands, yams and kola nuts. Eastern South America, passion fruits, peanuts. Andean highlands, pumpkins, strawberries, and potatoes. And finally, Mesoamerica, avocados, tomatoes, and corn. Agricultural geographer David Lanegran knows that locating these hearts, or origins of the food the world's population depends on, is more than just an intellectual exercise.
I find interesting about the whole question of origins is this is where the genetic diversity of the plants that we eat today is greatest. So we need to know where these domesticated hearths are so that we can go back and find the wild ancestors of our contemporary crops and develop a genetic base so that we can continually manipulate our crops, because people are constantly making genetically modified crops. Whether or not it's actually with the biological transference of genetic material across species or just selective breeding of crops, we're constantly manipulating plants, and we don't want to run out of genetic material. So for me, it's fundamentally important to know where these origin areas were and to go out there and collect seeds and genetic material.
Let's look at the origin, diffusion, and hybridization of one of the world's great grain crops, corn. The great cornfields of Middle America today came from ancient corn agriculturalists called maize cultures. One of those cultures is the ancient Pueblo people, sometimes called the Anasazi. They built these magnificent cliff cities that still stand today. Built them over 1,000 years ago in an area known today in the United States as the Four Corners region. As everywhere else in the Americas, the Four Corners region was first inhabited by people who subsisted by hunting wild game and gathering fruits, seeds, and roots. Exploiting these resources meant that these hunter-gatherers had to live in small mobile family groups or clans. That changed here with the domestication of corn. Stephen Nash studies and dates the slow but steady rise of maize cultures in the desert Southwest.
The earliest form of corn that's known from central Mexico is actually a wild grass, and it's called maize, but you wouldn't recognize it as such because the cobs are only about this big, an inch long. And 2,000 years ago, when maize is first introduced in the American Southwest, those cobs are like this. There's a site in east central New Mexico called Tularosa Cave, in which Paul Martin of the Field Museum excavated 38,000 of these little tiny corn cobs with a 2,000-year sequence in them. And over time, those corn cobs get bigger and bigger, and interestingly, they add more rows. The kernels grow in rows, and instead of having 4 or 6 rows, it develops up into 8 or 12 rows. So it's much more productive per cob as maize later on in the sequence. And by the time you get to the end of the sequence at Tularosa Cave, you can look at some of those cobs, and it looks like they're from roasted corn from 4th of July a few years ago. I mean, it looks like almost fully modern corn. The other interesting thing that happens in the American Southwest is that the corn diversifies genetically, so that there's a whole series of different strains of maize. It's not just one kind of corn.
So subsistence agriculture, which started many thousands of years ago, gradually began to give way in many places to another agricultural regime, surplus or commercial agriculture. This was a major change that accelerated agriculture's impact on the physical environment. More and more land came to be cultivated in an increasingly intensive way. And of course, surplus agriculture made it increasingly possible for philosophers and scientists to spend their time building knowledge instead of growing crops. Some of that knowledge was about agriculture itself. Knowledge leading to what is called the Second Agricultural Revolution. Step 1 involved agricultural land practices, such as crop rotation.
And the Second Revolution was focused on land fertilization, improving land, and mixing crops and animals together in a different way. The notion was you would raise crops to feed animals and eat animals. Before then, people had a much more vegetarian-type diet.
The next phase of the Second Agricultural Revolution was mechanization. A mechanization that, in the 21st century, has led to powerful machines for planting and harvesting crops of every kind. Mechanization occurred simultaneously with the Industrial Revolution. Agricultural labor, less needed in the new mechanized world, poured into fast-growing industrialized urban areas. And for the first time, geographical hypotheses about the spatial organization of agricultural practices began to develop.
I'm standing here in the Willamette Valley, an incredibly agriculturally productive place just south of Portland, Oregon. Why are the crops that we see here grown where they are? The first person to consider this in any serious way was a man by the name of von Thunen, who was a German economist in the late 19th century, who began to think geographically about the world around him. He imagined what agricultural land use would be like if there were one town, one isolated town on a flat plain at a time when farmers would bring products to market by ox cart. And he suggested that there might be a series of land uses, a concentric pattern around an urban area, with the first ring around the urban area being devoted to things like market garden vegetables and fruits and maybe dairying, and then farther out rings devoted to things like grain growing or livestock raising and the like. The insight that von Thunen had was that land use would be affected by things like the cost of transportation to market, the perishability of goods, and the cost of land. Well, things have become much more complex, of course, than the idealized model that von Thunen was looking at. And here we see a bunch of ornamental plants being grown, some of which will end up in gardens in places like Virginia and North Carolina. And they're being grown all the way out here. But in some ways, this still conforms to the von Thunen model, because here the combination of transport costs that are now fairly cheap and relatively inexpensive land compared to, let's say, the land around Washington, D.C., makes it reasonable to devote land all the way out here to the growing of ornamental crops like the ones you see here. So the principles that von Thunen was trying to articulate still apply, but in a much more complicated world than the one that von Thunen was looking at.
By the 20th century, agriculture was no longer dominantly regional or local. It was a big business, a global business.
When corporations got involved with developing machinery, and they would send salesmen out to kind of promote, let's change from using the old sigh, let's get to a harvester, let's talk about different kinds of cattle that'll produce more milk, cattle that'll produce more beef, instead of having that rangy Texas Longhorn, let's get some Herefords or some Angus over here, or, let's get rid of that old Spanish milking cow, let's get some nice Holstein Friesians in here. So you get people promoting agriculture as agents of change. And some of these are corporate, lots of them are corporate, but also the government got involved in this. So you get the state trying to have agricultural fairs, and let's get the farmers together and show them this big watermelon. And then after World War II, the government really got involved, and set up research stations overseas, the Borlaug, the so-called Green Revolution. And really, as a national policy, tried to change the agricultural production in various parts of the world.
With the rapid diffusion of modern agricultural practices and technologies, partly as a result of the Green Revolution, a revolution driven by corporations and genetic manipulation of plants and animals, two major global geographical policy questions have arisen. What should be grown where? And what should the over 7 billion people distributed across the planet be eating? Geographers bring their own perspective to these issues.
Everybody argues about this. Should you drink coffee? Should you not drink coffee? Should you drink Coca-Cola? Should you not drink Coca-Cola? Should you eat beef or should you eat buffalo? Should you only eat vegetables? Should you only eat fruit? Should you only drink water? And almost everybody's got an opinion on this. And for the geographer looking at the effect on the diffusion of technology, I see all these as a barrier to the diffusion of new crops, improved varieties of crops.
Now we're really just down to some of the main staple industrial crops, like, cotton, rice, corn, those kinds of things. I think there's a lot of potential to expand the options so that more people can eat more nutritious food. The problem is anytime you introduce an exotic crop, and by exotic I mean something that's not native to an area, anytime you introduce an exotic crop, usually you have a demand for water inputs or pesticides because those crops are not going to be able to beat off the native bugs. You're going to possibly need different kinds of fertilizers, so you're going to need a lot more inputs. And I think that's one of the tricks, that you can't just plant anything anywhere, that you have to think about the whole system in terms of what kind of inputs are going to be necessary.
So as we move forward, the question is, can we maintain the balance between what the technology does for us and the costs of that technology in terms of the way that people produce food, not only globally, but also critically locally? And I think what we're finding is that there needs to be a reorientation. Food needs to be grown closer to where people are rather than grown on massive farms and packaged up and stored and then shipped considerable distances.
The big problem with people getting enough to eat in our slice of human history is not our capacity to produce, but our capacity to distribute. And technically we can move food around, but politically we have big problems.
So we're living through an era of unprecedented changes and challenges for the agricultural system. There is currently enough food being produced to satisfy the caloric needs of the human population, but hundreds of millions go to bed hungry, and some die of starvation. This suggests that questions of food distribution are as important as food production. Moreover, in many places, the rapid rise in agricultural production has been driven by inputs that are degrading the quality of the soil and water on which human life depends. Shifts to more sustainable agricultural practices are underway, but the population continues to grow, raising serious questions about how the food system can keep pace. Geographic analysis is essential to confronting these challenges. We need to deepen our understanding of the impacts of different agricultural practices on places and environments, and of the ways in which food distribution systems and consumption practices in one place affect agriculture and land use in other places. We also need to recognize that what happens to agriculture is inextricably tied to larger political and particularly economic shifts. We turn to the latter issue in our next program, which examines the changing character and organization of economic activity on the planet. I'm Alec Murphy. Thanks for watching Human Geography, Making Sense of Planet Earth.